And then we come to also few graph algorithms. Those graph algorithms, some will fall under 3D approach and some will be solved using dynamic programming. I could have incorporated there, but separately we have written it. Then we will go for a computational complexity. That is basically classification of the problems, and different problems are under different categories. 4 categories are there. We'll discuss those things. And whatever algorithm we discuss, for every algorithm, we'll compute the execution time. This is basically the whole contents of the subject. Now, looking at the next, let's say, now let's go for analysis of algorithms. So as I told, I discussed the definition of algorithms. I told a little bit about design. Then let's come to the analysis. This is a prerequisite to understand the whole subject. Let's see, how do I make an analysis for the algorithm? I already told 2 things, if you remember. Analysis is made either from the execution time point of view or from memory requirement. Is it audible?
Yes, sir.
Yes, sir.
Yes,
So
sir.
from this two, but very often we make an analysis with respect to the CPU time or execution times. Now, when we make an analysis, we take some parameters for analysis. Now, if you look at this, so we must decide a computational model. When we decide a computational model, normally we consider a uniprocessor random access memory systems. We never consider for a multiprocessor system. There are also multiprocessor system. For those processor system, we sometimes make an analysis. But in our task, in our syllabus, we'll never consider this analysis with respect to multiprocessor system. We'll simply consider system is uniprocessor and where we have the memory random access. And these are, if you look at this, I'll say first point is memory access time should be same. And then there should not be any concurrent operations. The operation must be sequential when we go to find out the execution times. If we go for a concurrent operation, we will not be in a position to find out the whole execution times. That we'll consider also. Then I'm taking unit time. Unit time means, for simplicity, we assume that every instruction will take equal amount of time periods, and that equal amount we consider as unit time. Be it addition, be it multiplication, be it divisions. For now, the operation takes a little bit more and less time. If you consider addition takes less time compared to multiplication, if you can compare floating point division takes much more time in comparison to integer divisions. So even if the takes, we will only consider each operation, each instruction takes unit time. The weightage is 1. We will consider that. Then that will be considered if the instruction happens to be a simple instruction, like addition, subtraction, multiplication, division, like this. But if it is a function call, I will discuss, we will not consider the execution as a unit time. Remember, in case of function call, we will not consider this as a unit time over here. Function call will be treated separately. Remember this. And whenever we discuss, we'll also discuss the machine will be using a constant word size. Word size means if at all it carries out, all words may be of 32-bit, operations are of 32 bits. It's not that some words 18 bits, sometimes 8 bits, 16 like this. All words will be 32-bit operations. And analysis will always be made. Very important point. Remember that for large input. And when I say we'll go for a large input, it means either we'll have large number of inputs. In case of an array, I can say big array, 1 dimension, 2 dimension, or we can go for a single element, which itself is a larger one. I can say find out a number or search a number in an array. Then number of numbers are very large. I can ask you find out factorial of a number. Then we don't have lots of number, a single number, but that number itself must be very large. Then input size is very important to understand this. I can say graph. We have different type of data structure. If you remember, array, we can say size of the array. If I talked about the graph, what is the size of a graph? Can anyone say? Hello? अरे सुनाई दे रहा है? Is it audible?
Yes, sir. Yes, yes, sir.
हाँ, size of the graph को कैसे बोला जाएगा? How do I say size of the array? Yes, size of the graph. Size of the graph can be defined in two ways: number of vertices, nodes. Yes, or sometimes also in some problem, number of edges. If I come to a tree, ट्री का क्या बोलते हैं? साइज कैसे बोलते हैं? हाथ में दिखाते हैं क्या? सर इतना बड़ा levels. Very good. So one is yes. Node is the correct answer. Level is also correct answer. Height is also correct answer. So they are basically considered to be the input of a tree. So that is why input varies from one problem to another problem depending upon the data, which type of data we are taking. And last point is not so much of a concern. I say it's basically if we do a bitwise operations, we don't consider a bitwise operation to find out the execution time. We always consider every instruction takes unit times. This we do not consider. Is this page is understood little bit?
Yes, sir.
समझ में आया कि नहीं? अच्छा, एक दो चीज याद रखो. Every instruction we will consider unit time execution. Those which are simple, addition, subtraction, multiplication, division like this. But if it is a function call, we will treat it separately. And input must be large. Okay. With this, we'll proceed right now. Now, first, let's come to determine the execution time. Because as I told, we'll make analysis based upon the execution time. So the question arises, sir, how do we find out the execution time of an algorithm? So, कैसे निकालते हैं execution time? Let's see. To find out this, we'll see number of primitive steps. Primitive means the simple steps that are executed except for the time of executing a function calls. We'll only consider the primitive steps. Function calls will also be treated but separately. Let's go for first. See in algorithm how many primitive steps are there, how many function calls are there. The primitive steps execution will be treated as unit time and function call execution will be treated separately. I'll discuss it. Then most statements, as I told previously, even if they take small difference of time for execution, but we will consider also the statements roughly require same amount of time periods. That consideration will again make when we go to determine the execution times. With this, now we'll not design algorithm right now. Given an algorithm, look at the statements. Given an algorithm is given. To find the total execution time, we will find execution time of each statement. Let it be Ti, and I stands for the ith statement. You may consider equal time, or if you take unequal time, you can say execution time of each statement. Ti is the execution time of ith statement. I can say T1 is execution time of the first statement, T2 execution time of the second statement, and like this. Then number of times the ith statement gets executed. The next is the number of times the ith statement gets executed. If I say the ith statement, let's say I will say this one statement execution time in 2 seconds, and that statement will execute for 4 times. The execution time will come out to be 8 seconds, which is added in the whole algorithm execution time. So number of times the statement gets executed is Ci. Sometimes we call it as a frequency count. Remember this. The number of times we call frequency count of the statement in the algorithms. And now if you come to the total time of execution, it is sum of Ti into Ci. For I varies from 1 to number of statements. If I say 10 number of statements are there, I will vary from 1 to 10. And some statement, as I told, is executed for 5 times, some 10 times, like you say, every statement execution time into its frequency count, and sum of this will get the total execution times. Is it understood right now?
Yes, sir.
Yes, sir.
Yes, sir. Yes. Now,
Yes, sir.
before showing this, let me tell. To find out the execution time, we need to know this. So let us see the algorithms, and we will not go to the first initially. We'll go for the second one. So now we are interested to find out the frequency count of each statement vis-a-vis the frequency count of the whole algorithms. If I know the frequency count of each statement, I will go on adding it, and finally I will find out the frequency count of the whole algorithms. Means algorithm will execute how many number of statements. We will not consider right now execution time of each statement. Our interest is only to find out which statement will be executed how many times, and finally the total number of statements to be executed, assuming that each statement takes equal times. This is the assumptions. Now, with these considerations, let's come to discuss some algorithm and their corresponding statements frequency count. I remember this frequency count we are finding out to calculate the execution times. Because we will calculate the execution time, we will only consider the statements which are executable. There are some statements available in a program or algorithm, and they are non-executables. Normally, algorithm we avoid. Program sometimes we write non-executable statements, but remember, non-executable statements will not be considered when we calculate the execution times. That is why their frequency count will not be considered. So we will not consider the frequency count of the statements which are non-executable. Few examples I say, your declaration statement is not an executable statement, but initialization statement is an executable statement. Remember this. So on every simple statements, the frequency count or the weightage would be considered as 1. With 1 weightage, we'll find out number of times it gets executed. With this understanding, let's come to the first algorithm. Algorithm 1 over here. I have given different names. Algorithm 1. Can you tell, should I consider this declaration statement? Tell me yes or no?
No, sir.
No, sir.
No, sir. We will not
No,
consider.
sir.
It's a statement, but it's not an executable statement as long as execution is concerned. Then, should I consider this statement as assigns to 0? Yes or no?
Yes,
Yes, sir.
Yes. What would be the frequency count?
1.
1. Very good. Next
One.
statement will also be executed once. Understood to everyone?
One.
Yes or no?
Yes,
Now
sir.
comes this while statement. Oh, sorry. I have not updated I over here. Let me
Yes,
say
sir.
that the I will be updated. Okay, I made a small mistakes. I'll rectify this. Okay. I will be increased by 1 unit. Can you say how many times this while statement executed if I is incremented
11.
by 1 unit every time?
11 times.
11
times.
11.
9.
11.
11.
Remember this,
11.
counter starts from 0. Let me also tell to everyone. The counter starts from 0. It will be executed for 0, 1, 2, continue up to let's say 10. In 10, it will be satisfied or not satisfied. If I equal to 10, the condition is satisfied or not satisfied?
Not satisfied.
Not satisfied.
Yes, not satisfied.
No.
So it will only continue to satisfy up to 9. So that
9.
is why the while statement will be executed for 0, 1, 2, up to 10. 9 times satisfied, once not satisfied. So if I start counting from 0, it will be executed for 11 times. Condition is satisfied for 10 times. 1 time condition is not satisfied. So the inner statement will be executed only 10 times. Remember, one statement is there, I is updated by 1. You can write down I plus plus or less than 10. I made a mistake. You can, let me say the while is replaced by I plus plus less than 10. You can update like this. While I less than. Don't bother about contents of the algorithm. And this return statement will be executed once. If you just remember this, if you see the frequency count, are you in a position to compute, now calculate the total frequency count f of n? कितना
Yes,
आएगा?
sir.
हाँ, बोलो कितना आएगा? हाँ,
24.
24.
24.
Are you getting this
24?
24? Write down this is 24. You all write down this. So this algorithm will execute 24 number of statements. All 24 statements are not of same type. Some are assignment statement, some are conditional statements, some are addition statements, some are return statement. But however, assuming they will all take equal time, I can say it will take 20, it will execute 24 number of statements. I think it is understood right now.
Yes,
Yes,
sir.
Yes. Yes. Now
Yes,
let me
yes.
say the next one. The next one, second one, algorithm 2. Can you say again same way? Can you say this statement will be executed? Yes or no? It's a declaration
No.
statement or initialization statement?
Initialization.
Initialization. It will be
Initialization.
executed once. Yes, will be executed once. How many times this I will be executed?
N
N
का
plus
value
one.
अच्छा n.
And
Yes,
time.
I
Plus
started
one.
from 0. Yes, let me write down. I started from 0. Will be executed for 0. Will also be executed for I equal to 1. I equal to 2. Continue to be satisfied up to n minus 1. The moment it became n, the moment it became n, will it be executed or not? Executed, but will it enter or exit from the loop?
Exit.
Exit from the loop.
This is, yes, exit from the loop, but the statement will be executed for how many times? N times or
N
n plus
plus
1
one.
times?
N plus one.
Very good. N plus 1 times. If I start counting from 0, come out to be n plus 1. Everyone must understand this. And any statement available inside a loop will always be executed one less than
N
the
times.
loop statements. Always be n. And this will be executed, let's say, once. If I write down this, now, can you compute the total execution time right now? Can you count it and write it over here?
2n plus
2n
three.
plus 3.
2n plus
2n plus 3.
So we will write down this as 2n plus 3. So I'm writing here your fn became 2n plus 3. So given an algorithm, it is very simple. We got to know what is the execution time, or sorry, how many or the frequency count of these algorithms. Okay, so let me check just once whether anybody is waiting. Just check once. 1 minute. No one is voting. I think there are 3-4 students were waiting. Now, someone was now look at this. Yes. So we got the frequency count right now. Now we again come to the next slides. Yes.
So in IES, why is this statement not considered?
Declaration statement has nothing to do with execution. Declaration statements are exclusively made for the compiler. It is an instruction to the compiler to allocate a memory, nothing else. So during execution, those declaration statements will no more be there as a executable code. It will simply be allocated a memory, and that occurs during compilation, not at the time of execution. Is it understood?
Yes, sir.
Yes. Now, coming to the next one over here. Yes. So we will, I will connect it twice today, okay? We'll take 1 hour. Otherwise, now look at these algorithms. So everyone will suggest me. Now, so flag may either be true or false. Let me say the flag is true. Let me say that the flag is 1. Okay? Flag is non-zero, like this, the integer. If it is non-zero, will I execute this statement? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
What is the frequency count?
One.
What is the frequency count? Very good. Will I enter to the
Yes, sir.
for loop?
Yes,
Yes,
sir.
yes, sir.
Very good. Very good. This for
N.
loop will be executed from 1 to
N.
n. 1 to n means
N plus
N
one.
n
times.
times, n plus 1 times.
N plus
times.
1.
Plus
No,
1.
N plus
n times, but it will be executed n plus 1 times. The last time the condition will not be satisfied. Understood?
Yes, sir.
Understood?
Yes, sir.
It will be executed starting from 1 to up to n plus 1. It will be satisfied up to this. Here it will not be satisfied, but the execution will occur. Okay, that is why I wrote it as n plus 1. Possibility is clear. Now after this, yes.
सर आई जब 0 से होता है तब n+1 होता है ना?
नहीं नहीं, बात जीरो से नहीं है, बात जीरो से नहीं है. Now look at this. Forget about zero. जो माथा में दिमाग में था उसको मतलब बाहर फेंक दो. Now try to understand. For statement gets executed for I equal to 1. Yes or no? Tell me.
Yes, sir.
Yes, sir.
Yes. Will also be executed for I equal to?
2.
Yes or
Yes,
no?
sir. Yes, sir.
Yes.
Will it continue to be executed for I equal to n? Yes or
N.
no?
Yes, sir.
हाँ, यहाँ तक satisfy करेगा. इसके बाद इसका value this will become n plus 1. But this value will be executed. Condition will not be satisfied. It will come out of this. But that for statement will start its execution from 1, 2, 3, 4 up to n plus 1. Hence, it will be executed for n plus 1. I think it is clear now.
Yes, sir. Yes, sir.
जब इश्यू को पढ़ाते हैं इश्यू को समझो, जब वो पढ़ाएंगे जीरो उसी को समझो. Now, next, if you come to right now the next statement, S1, I always told S1 will be executed for how many times? One less than this,
One
n
less
times.
than n times.
Will you execute else part when n is equal, the flag is non-zero?
No, sir.
No, sir.
No, sir. Now I'm writing this. So अभी count करके बोलो कितना आया? 2n
2
plus
n
2.
plus 2.
2 and plus 2.
Very good. It became 2n plus 2. You write when flag is non-zero. You have all understood this. Then let me go to when flag is equal to, let's say 0. Let me say go for the next case. When
N
flag
square plus
is equal to 0. If flag is equal to 0, will I execute this statement? Yes or no? It will become false. What will I execute?
Yes, sir.
Yeah.
Yes, sir.
Will execute it. It
Yes.
becomes false. Will come the else part. Now, should I consider the else statement for frequency count?
Yes, sir.
No, sir.
No, sir.
Else
No, sir.
statement is
No, sir.
not remember this. Else statement will not be considered. But will enter here. How many times will execute this?
N2 plus 1.
N2 plus
Sorry,
1.
it's a mistake again. It is I wrote intentionally. It is 1 to n square. By mistake, it became n. Okay, you consider 1 to
N square plus 1.
Very
Square
good.
plus
N
1, sir.
Yes, you modify it. Whatever I'm saying, you write down. You will modify it. N square plus 1. Then here, how many statements? S2 and S3. S2 will
two
be
and
executed for how many times? Very good.
N square, N square.
S3, N square. Can you add it and tell me the answer?
N
Yes,
square
sir.
plus
N square,
Square. 3n square plus 1.
Very good. Plus 2. This
Yes.
1 plus this 1.
Yes, sir.
So now number of statements became 3n square plus 2 when flag is equal to 0. Are you getting a same frequency count or you are getting different frequency count for the same algorithm?
Different.
Different.
Yes, when flag is equal to 0, we are getting 3n square plus 2. When flag is equal to non-zero, we are getting 2n plus 2. So let us connect it again. Okay. Now you do one thing. I'll disconnect, connect it again. Few more students are also joining on time. So now let's connect it again. Sixth semester. Is it audible?
Yes, sir.
Yes, sir.
Yes.
So this you have understood, and do a modification for I equal to 1 to n square. Okay, that became n somewhat. So make it like this. So let's come to the next part over here. So the first algorithm 3 I discussed. Now let's come to the fourth algorithms, where we have two parameters, let's say A and B. If you look at these two parameters,
Sir, share your screen.
oh, I have not
Screen
said
not
it.
able.
Sorry. Oh, देखते हैं फिर कैसे करते हैं उसको. अच्छा, okay. Photo screen. Now is it coming?
Yes, sir.
Yes, sir.
Yes, sir.
हाँ,
sir.
बीच में बोल दिया करो, because मतलब I'm not so acquainted with this. With lots of pain, I prepared this slide. I never prepared. Now let's come to the next algorithms to find out the frequency counts. Algorithm 4. There are two input parameter A and B. Look at this. If A is equal to B, then how many statements are executed? Tell me. If A
One.
is equal to B,
2.
how many
One.
statements are executed? Only 2. So this
One.
statements frequency count 1, this 1. So I can
Yes.
say if A is equal to B, the frequency count f of n will be exactly equal to 2. Are you satisfied with this?
Yes,
Yes,
sir.
Yes, sir.
Yes. Now let's consider n a greater than b. When a greater than b, we will not execute this return statement. We will execute this statement. We'll execute this else statement, if statement. We'll execute this for statement and S1 and this. Even if it is
2n
greater
plus
than B, yes, if it is greater than B, we must execute the if condition. It will become false, else if condition will become true. Remember, else is not an executable statement, but else if is an executable statement. Now let's find out the frequency count. This is 1, else if statement is 1. This for statement I already discussed.
N plus 1.
See it again,
Plus
n
one.
plus 1, S1 will be executed,
1.
and return statement will be executed once.
1.
If you go on counting it, possibility will come out to be
2n plus 4.
2n plus
2n
3.
plus 4.
4.
Plus 4.
Very good. Doesn't matter. Later on, you will not fight
Four,
with 3
sir.
and 4. 4, 3. Today you are fighting. Later on, you will not argue with me also. I'll tell it. Bye. Later on. Now, this is understood when n is greater than b. Now, when n is, let me say, yes, equal to n is less than b over here. If n is less than b, see which statements we will not execute, then we'll see the frequency count. Which statement will execute? If you see, will execute
If.
this
Else if.
statement else if
If
will
written,
come to else, but
Loop.
else will not be considered. We'll come to
Yes.
this, and this is again n square. Remember, this is n square. Now we'll execute for S2 and return. If I go on writing frequency count 1, frequency count 1, and this frequency count, I'm writing it n square plus 1. Remember, you need to update it by n square. By mistake, I made it n. Yes. S2 will be executed for how many times? N square.
N square.
Yes, this will be executed for once.
1.
one,
Can you sum it up and tell me?
2n square plus 4.
Very
N
good.
square plus 3.
It became 2n square plus again 4.
plus 4.
Yes. So we got the frequency count. Now, how many frequency count you got for the same algorithm?
3.
1, 2,
Three.
3, 3. So first we started with the algorithm. We'll have 1 frequency count. Then we see the some algorithm has 2 frequency counts. Means in some situation algorithm may execute less statements. Some situation the algorithm may execute more statement. And now we are finding algorithm will execute 3 different frequency count depending upon the situations, depending upon the inputs. So it may also cross 3. It may become 4. If I go for a switch case statement, you'll maybe getting, let's say, 4 different types of frequency count or 5, but we'll not go beyond that. Now, let's discuss now how to find out the frequency count when we have inner loops. Now, I only discussed with a single for loop. Now, let's discuss for multiple loops. Okay, carefully you listen. See, when we let me also tell one thing. When we discuss algorithm, I may not write down the declaration statement like I and J. Those declaration statements are not required. One comment you write down. S1 happens to be a simple statements. One comment you note down, which I suppose, right? S1, which I told, S1 is a simple statement. Is a simple statement. And addition, subtraction, we are least bothered about the statements. It could either be a simple addition, subtraction, multiplication, division like this. So now let's see. Carefully you listen. I will also do carefully, otherwise I may also make a mistake. Now look at this. How many times this statement gets executed?
N plus 1.
N plus 1.
N plus 1. Yes. Absolutely, there is no problem. N plus 1. Now I'll write something, please take it seriously. When I is equal to 1, oh, visibility mirror. Let me go for a visibility. One side, blue color. So black color. Now come to this. You come to this. Very good. When I is equal to 1, how many times the for loop gets executed? Because it enters
N
in
plus
the
N plus 1.
Very
2
good.
times.
Very good. That way.
2 times.
Yes. See the way I am finding it out. When I is equal to 1, we enter to the inner loop. We enter inside this loop. Now this for statement will be executed for n plus 1 times. All have understood this. Again, we will. So when this for loop gets executed for n plus 1 times, can you suggest how many times the statement S1 gets executed?
N plus 1.
N times.
N times. Then I'm doing it sequentially. When I became 2, again it will enter to the for loop. When I will become 2. When I become 2, again the inner for statement will be executed for how many times?
N plus 1.
N plus 1. N plus 1.
times. And S1 will be executed for n times. Should I consider the same thing will also be repeated for I equal to 3?
Yes, sir.
Yes, sir. Yes, sir.
Will also occur for I equal to 4, 5, 6, and finally for I equal to n, this will also be executed for n plus 1 times and n times.
Yes, sir.
Now, coming to this, when I became n plus 1, will the inner loop be executed? Yes or no?
No, sir.
No, sir.
No, sir.
No, sir. No,
No,
sir.
sir.
We understood up to this.
No.
And yes, After this understanding, I'll come, the return statement will be executed once. Let's do the addition here. Addition, you all are very keen. Now I can write down my frequency count. F of n will be this n plus 1 plus this one plus this n plus 1 is added how many times?
N times.
Time.
N
Can
into N.
you, should I go on writing from here? I can use a multiplication n into n plus 1.
Multiplication. N
Very
plus one.
Multiplication N into N.
N plus 1. ये हो गया. Now this n is added how many times?
N
N
times.
This n is
N
n
times.
times. So it will be
N
plus
square.
N square.
n square or n into n to start with. Sorry. N into n. ये नहीं है n into n. Is the statement understood everyone? Yes or no?
Yes.
Yes, sir.
Yes,
ये
sir.
समझ में आया कि नहीं आया? अच्छा ये अगर समझ में आया, now you keep a screenshot. I'm moving to the next slides. Possibly this will be my last slide for today's class, but try to understand it very carefully. Now the left hand side we discussed. Let's come to the right hand side. Very quickly you will answer the way we proceeded in the previous example. Same way we'll proceed also. Now tell me, how many times this statement gets executed? Everyone should say
N plus 1.
N plus 1.
very good. Very good. N plus 1. So quickly we'll go to complex problems. Now let's come back here. Look it at minutely. Previously, if you compare the left hand side, it was j equal to 1 to n. No one is 1 to n. It is I to n. It is I to n. Hence, let me write it here. When I is equal to 1, let me write in other way also. I am writing it here. I, then for loop, and then I am writing statement S1. Now tell me, when I became 1, your j will start from 1 to n?
Yes, sir.
Yes, sir.
Yes,
So this
sir.
for loop will be executed
N
for how
plus
many
1.
times?
N plus
N
1.
plus 1.
N
Your
plus 1.
S1 will be executed for n.
N.
First statement is understood everyone, yes or no? Yes.
Yes, sir.
Then we go to the outer loop. Then we go to the outer loop. I will become 2. My inner for loop will start varying from 2 to n. If it varies from 1 to n, it was n plus 1. If it varies from 2 to n, will it be same n plus 1 or will it be reduced to n?
N.
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 Yes. If this is n, this will be
N minus 1. N minus 1.
N minus 1.
understood everyone. Again,
Yes, sir.
when you go to the next iteration, when I entered the inner loop, when I became 3, my inner loop will vary from 2 to n or 3 to n.
3 to N.
3 to N.
If it is 3 to n, it will obviously be
N minus
n
1.
minus
N
1.
minus
It will
1.
become n minus 2.
N minus 2.
Yes. If I continue to do like this, the moment my I became n, the for loop will be executed how many times? N to
2
n.
times. 2
No,
times.
once.
1.
N. Sorry, 2 times. Sorry. I
Two
made a
times.
mistake. Sorry. It will be 2 times, and this will be executed once. Sorry. N to n, it will be executed for n, will also be executed for n plus 1. Okay? It will be executed for n, will also be, which is true, will also be executed for n plus 1, became false, so 2 times. Very good. Correct answer. Possibly Asutosh, who is giving the answer. Asutosh है ना नाम क्या है मैं भूल गया. So now
Arpit.
look
Yes.
at this. Huh? क्या नाम है? Somebody told. Anyway. So now if you come back to this, the last return statement is once. Is it understood? Yes or no? This part
Yes,
is
sir.
important.
Yes, sir.
Then I'm coming to addition. Addition anyone can do. If I right now start writing f of n is equal to, tell me n plus 1 first statement. Then if I come to for, it started with कहाँ से शुरू होगा addition? n plus 1 to 2 or 2 to n plus 1? 2
Say
plus
2 to n
3 up
plus
to
1.
n plus 1. Yes, both are same. I can go from 2 3, 4, 5 up to n plus 1. Then the last loop, if it starts from 2 to n plus 1, the S1 statement will start from
1 to n minus 1 to n. 1 to n.
1 to n.
N.
Yes. Is it understood? Yes or no?
Yes.
If you have understood this, let me erase this part and write down this final expression. Let me write down the final expression. Tell me little. Acha, should I do the addition n plus 1, or I can write down this as, look at this. I can say n is 1. I can say my n is 1 over here.
Yes.
And then I can do addition from 1 to कहाँ तक चलेगा?
n
बोल
plus 1.
सकते 1 plus 2 plus up to n
N
plus
plus
1
one.
is equal to
n plus 1.
क्या होगा?
n plus 1 into n plus 2 into by 2.
into
n
N
plus 2
plus 2 divided by 2.
divided by
by
2, and
By
this 1 to n will be n into
n
plus
plus
1
yeah.
divided by 2.
Plus n by 2.
हाँ, प्लस कर देंगे, ये प्लस कर देंगे, ये प्लस कर देंगे, and this will also be plus. It will be n. It will be n. Sorry. Plus this term plus these terms. Tell me up to this.
also.
कहाँ ये प्लस 1 का ले लिया ना, और आगे का ये प्लस 1, ठीक है, प्लस 1 कर लो. I will not fight with this. If you tell 1, एक के लिए कुछ फर्क नहीं पड़ा. Right, very good. Plus 1. Tell me up to this it is understood, yes or no?
Yes,
यहाँ
sir.
पर समझ में आया कि नहीं
Yes.
आया? अच्छा,
Yes,
अभी
sir.
5 मिनट बाकी है. You can ask small doubts related to this what I discussed. But let me tell what I discussed today. I only discussed how to find out the frequency count of an algorithm, which is the sum of the frequency count of every statement available in the algorithms. That I only discussed. I didn't discuss made any analysis. I'm not going to find out any execution time. Our focus was to find out how many statements have to be executed, assuming that each statement takes equal amount of time period, assuming that all statements are simple, no function call is there. With this assumption, we only found the frequency count. We'll see its use in the next class. Now, anyone has any doubt can ask me right now.
सर
हाँ बोलो.
काउंट करते हैं.
हाँ नहीं डू का काम नहीं होगा. डू का कुछ काम नहीं है. डू सिर्फ बोलता है यहीं से शुरू होगा.
Yes, sir.
एल्स भी वही बोलता है. एल्स बोलता है यहीं से शुरू होगा. एल्स का कुछ काम नहीं है. डू का कुछ काम नहीं है. वो सब लिखने के लिए है. दैट इज मेड फॉर कंपाइलर. काउंट करो ज्यादा फर्क नहीं पड़ेगा. आफ्टर ऑल आई विल शो यू.
Yes, sir.
काउंट आल्सो डजंट मैटर. आई विल शो इट. एनीवन एल्स हैड एनी डाउट? कुछ डाउट है तो पूछो, वरना हमको फिर
कंडीशनल स्टेटमेंट्स में
हाँ बोलो. कंडीशनल में क्या हुआ बोलो.
सर उसमें क्या लेंगे अगर कंडीशनल स्टेटमेंट है?
नहीं, कंडीशनल इफ स्टेटमेंट का तो हमेशा कंसीडर करेंगे. एल्स का कंसीडर नहीं करते. एल्स इफ का कंसीडर किया जाएगा. कंडीशनल स्टेटमेंट इज सिंपल स्टेटमेंट्स. कंडीशनल स्टेटमेंट
मतलब वो जो टर्नरी ऑपरेटर वाला होता है, टर्नरी ऑपरेटर जो होता है.
very good, very good. When we are coming to a ternary operator, you can break it a if statement, then you can consider every ternary operator can be broken to if else. है कि नहीं?
Yes, sir.
अरे टर्नरी ऑपरेटर तो एक सुपरसेट ऑफ इफ एल्स का है. सो तो इफ एल्स कर सकते हैं, वरना अदरवाइज द होल ternary operator will be considered as a unit statement provided the inner statements are simple. Okay? Whole ternary operator will be considered as a unit provided the inner statement of ternary are simple statements. No function call is there. We will come to this. Anybody else has any doubt, or I'll close the meeting?
No.
Let's close it. Tomorrow we'll start from here. Okay, thank you.
Thank you, sir.
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 Okay.